Hey class, we are going to do logarithm functions today, 4.3. So I'm just going to do the first part of this, and that's going from a logarithm to an exponential to a logarithm. Much easier just going from one form to the next. But let's talk about first what a logarithm is, okay? A logarithm is just an exponent, okay? That's so important that a logarithm is just an exponent. Make sure you understand it. A logarithm is an exponent that we need to raise the base to get the function value, okay? So logarithm is just an exponent. What is that exponent that we need to raise the base to get the function value, okay? So you see what I have here, which is a base must be raised to in order to get y. Now I give you all the parts of logarithm. This is the actual logarithm right here. Okay, this is logarithm right here. X equals log base a y. X equals log base a y of y. Okay. Now, you all, let me point something to you. Your base will always be below this g right here for the log, the word log. So your base is always here. Okay. Need everybody to know that your base is always here. Now, if you remember from section 4.2, I told you two things. I told you that the base has to always be positive, and I told you the function value has to be positive. Those two things have to be positive to be true. And I told you it would come back again. So this is where we making sure it comes back again. Okay. Now here is x equals the log. This is our base right here, base a of y. That's how we say x equals log base a of y. Okay. All of them have its part. Logarithm is an exponent, so this x right here represents, anytime you have equal to on this outside, it's here, but it could be equal to x over here. It represents your exponent. Okay, this thing the logarithm statement equals represents your exponent. A, once again, is your base. That has to be positive. Remember that. Has to be positive. Y, this represents your function value here, your function value of it. This is just how it's written, okay? So you have to know the parts of a logarithm. Let me write it over like this so you all can understand. Log, and I'm going to use capital letters just so you all will see. Right here, always go the base. But yeah, let me put it in a different color so we can see it. Okay, your base is always here. Your base is always lower than your G. Okay, that's your base. It will all of your function value goes here. Okay, function value. And it will always equal an exponent. Now, if you need this to guide you by how do we write and what the parts of the logarithm statement is, go ahead and make sure you write that down. Because this is how we read a log statement. Log base, log base of the function value equals the exponent every single time. Know the position of each thing. So here you all, on this outside, you see that? That's your exponent right there. A right here is what? Your base. Right here, anything that's right here is your function value. You got to know those three positions. You have to, okay? And that's especially when we go to 4.5 and we solve these logarithm equations. You have to know the different position. Even when we do some later in this section, you have to know each position, okay? Now, look what I say. Exponent is x, like I said. A is a positive number. It can't be 1 at all. Remember, it can be between 0 and 1. It can be greater than 1, but it cannot be 1. And y is your function value. You all, remember I said this, even in 4.2, these two must be positive. Has to be positive. X, our exponent, can be whatever it wants to be. X can be positive or negative. The restriction is not on the exponent. The restriction's on your base and your function value. So both of those got to be positive. Okay. Now, you all, what I'm doing here is I'm showing you an exponential and a logarithm because they're inverses of each other, right? When I show you this, I'm showing you each part. So you got to see each part. And each part got to be equivalent for both of them, okay? So look at this here. How do I go from exponential form to logarithm form, okay? Exponential form to logarithm form, okay? So as an exponential form, this is exponential form right here, right? You all see exponential form. I am breaking this exponential form for you. Look, I'm giving it to you. I'm telling you what every part is. Look at it. A raised to the x equals y. A raised to the x equals y. For an exponential, this a is our base, x is our exponent, y is our function value. When you are talking about an exponential, look at the form of it. Okay? Now, guess what? An exponential form can turn into a logarithm. Okay? Because we can write it like that. So, look at logarithms. Same thing I give you here, but I just put x over here. Log base a of y equals x. Same thing. A is my base. You see y is my function value, and x is my exponents. Okay? Let me put function value right here. Okay? So, you all, we can go from one form to the next by knowing each part and where each part is when you have a certain form. For an exponential form, do y'all see where the base is? Y'all see where the function value is, right? For a logarithm, do you see where the base is? Basis, do you see where the function value is in order to write these parts? So I give you a concrete example here. If I have 2 raised to the third equals 8, I can change that and write that as logarithm, okay? Logarithm would be log, remember my base is this, base 2 of 8, the function value equals 3, okay? So, and I have the arrow going one way, and honestly, the arrow could go both ways because you can go from a logarithm to an exponential and vice versa. You just have to know where the parts at. So make sure as you're writing this down, you all, make sure you label each one of these parts so you can get in the right place. Make sure you do that here too, okay? And you can go from one to the next. Like you can go from a fraction to a decimal and vice versa. You could do the same, this is the same thing with a logarithm and exponential. Now that's what we're about to do right now. We're about to go from one form to the next, okay? We're going from one form to the next. We can go from exponential to logarithm. We're not solving anything. We're just going from one form to the next. And then we're going to go from logarithm to exponential. Okay. I need to talk about 2 bases before we do this. These bases are in your calculator. And I'm going to show you this on the calculator in just a second. I need everybody to write the common log. Everybody has to know common log, which is base 10. It's a log with a base of 10. We do not write base 10. This is not what you're going to see. I'm just writing the formal way to do it. Like this is when you're talking about base 10. But this is how you're going to see it. When it's base 10, you're going to never see a base here. That's the only one that does not show its base. And that's base 10. Even in your calculators, you all, that's the only base you have in your calculator right now is base 10 and base E. And I'll talk about base E in just a second. But you don't see a 10 right here at all. Now, this is the form where I'm just showing you, if you're talking about it, this is what you see. This is the only one where the base is not written. Okay? Now, the next one, natural logarithm. And that's log with a base E. Remember, I taught you E in 4.2. E is equal to 2.7 something, something, something. E is like pi. So when we talk about logarithm base E, we do not write it this way at all. This represents natural log, you all. Ln refers to natural log. Okay, y'all got to understand that Ln refers to natural log. And this is how you know base E. So you all need to study this because I shouldn't get the question, which one is base E? No. If you study and memorize this right here, you always know ln always represents base E. Log without a power represents base 10. Okay, so you got to study. You just have to memorize this, which one is which. Okay, you're going to see ln. Anytime you see ln, the problem, we know you should think automatically that's base e. When you see log with no base, automatically think that's base 10. Now, I'm going to pull out my calculator to let y'all see the two on my calculator. I was just using my calculator earlier. Now, you all look here. Do y'all see, I don't mean to press the 7. Y'all see what I have highlighted right here, log? That's your base 10 right here. You don't see a 10 with it. It's not going to be written as the base. It's understood. The next one, right here, ln. That, you see the two, right? Log and then ln. You see the two right underneath each other. Okay? That's base E. ln is base E. Right here, ln is base E. Okay? Log, this is base 10. Those are the two that you use in your calculator. Those are the only two bases you have in your calculator. Is base E and base 10. Okay? So you have to know which one is which. Okay? Now, you all, once again, we say common log. When we say common log, that means base 10. And this is how it's written. When I say natural log, this is what I'm talking about, ln. And I know it's a base E. We don't write it. Okay? Got to know this. Okay? Now, let's go to convert one to the next. Okay? You are given an exponential equation and you need to write it in logarithm form. So let's come back here. Okay, let's come back here. You see, you're given this. Now we got to go to this. Look at all the parts so we know where to put them. Okay, so let's do it. We're given 81 raised to the 1/2 equals 9. Well, if I'm writing this as a log, first of all, I'm saying log. My base go by G, 81. Remember, it's the function value. Function value. This is my function value right here. So of 9 equals my exponent, which is 1/2. I have written this in logarithm form. That's it right there. Now, let's do it. The next one. Everybody, when we do log, what's our base? 3. We write our base here. The function value is next, so everybody should say 5 equals my exponent, which is x. Okay? Log base 3 of 5 equals x. Okay? Now, hope everybody getting those two. Let's do number 3. We got to write it as a logarithm statement. So, log, what's my base here? Hope everybody said 10. Do we write base 10? No. It's understood to be base 10. So we leave it like that. Base 10, we see it right here. We don't write it next to log. Okay? Now, the function value, 10,000 equals our exponent, which you all should be saying 4. Okay? Next one, the last one, where we have to write it as an exponential, as a logarithm, sorry. Let's do it. Log. Everybody should tell me my base is 2/3. Even though it's a fraction, you got to put it right here. What's my function value, you all? You should tell me 27/8. And this should equal to our exponent, which is -3. Now, we're going the other way around. Is everybody with me? We're going the other way around. I'm giving you log, and you need to come back with the exponential. We're not solving anything here. You're just going from one form to the next. That's all we're doing. Okay? Now, write each log equation into exponential forms. So we got 3 log. We write it in exponential. That's what we're doing here. Remember, you got to see, that's why I said you got to know positions. So we should know where base is. We should know where exponent is. We should know where function value is so we can write it correctly. Now, let's do it. Okay. My base here is 7, because remember the base is always by G, lower G, right? So 7. My exponent is what the log statement equals, which is 2. And my function value is always inside, right? So that is my exponential statement. 7 squared equals 49. Okay. Let's do 6. And I hope you all are doing it along with me as I'm doing it. My base here is A, you all. My exponent is 0. And my function value is 1. And this is a very true statement. Anything raised to the 0 power is what? 1. Okay. Now, look at number 7, you all. Look at number 7. ln pi equals x. Well, what's our base if it's ln? I hope every last one of you all said e. Okay. Because it's ln. So e would be my base. I automatically know that. My exponent is x equals to pi. So we have written these. We've converted back and forth. We go from one form to the next. Is everybody with me? We went from one form to the next form. Okay, we went from logarithm to exponential and exponential to logarithm. Okay, that's it.